diffraction, they'll not go waste. What all you purchase this blade, 1 rupee, 50 rupees, sir, 51 rupees unnecessary, you're asking us to spend. The total diffraction chapter you can understand with this experimental setup. You have to pass through not this gap, please. So what is the slit now? So this is slit, the yellow color gap, the narrow gap. This will be a slit. Now you can try this. You take the laser gun, laser beam, and pass it, and you can vary the distance between slits. You do one thing: fix one blade, and the other blade is make it movable. How to fix? I think you should know that one. Fix it to cardboard, anything. You take some plaster, adhesive tape, then put that plaster here like this to the cardboard. No, it'll get stuck, and this is movable. You ask any family person to move that, and you have to make this very narrow. As you increase and as you vary the distance between the gap, this yellow color gap, no, you can see the uncertainty. Okay, let's come for this one. Now, the position and momentum here. And there's one best example is what I'll try to give. The last one, the small topic, I'll give an example so that'll be easy for you. So this is these are the photons. Mm-hmm. So when I send the photons here, the photons, I'll just pick up some color. Okay, this one, yeah. The photons, these are the photons. So what will happen to photon when the width of slit is there? So they'll try to go straight. Nobody's objecting it, so they'll try to go straight. Then you want to define the position of photon here. So I think you're not certain, no? You're not certain. And are we able to define the momentum? As I say that as they're moving straight. This is the momentum. I'll show the velocity. It'll be very easy for you now. So what is uncertain? Which photon, where it is passing is uncertain. Am I right? Say this one, this is a slit. There's a gap. No. So what you are certain is all the photons are moving straight. So how do I come to know? You place a screen here. You place a screen. And when you place it, that screen there, and what you notice that all the photons will come and strike in this region. So there's a region in which photons strike. Agree this? So in this region only it will strike here. And we are very sure, what we are sure, the momentum, that they went straight. So momentum as we are able to predict exactly. Then which photon, where it is, we are unable to predict. We just see the beam of light is passing here. So now the position of photon, we are not certain. We are not certain. So I'll decrease the width of the slit. As I decrease the width of slit, then as the slit becomes narrow, and as I make it more and more narrow. So let me make it more narrow here. And then what when I am able to say that as the photon is passing through this slit. Now here open the photons will come here. We are not certain like which photon where it is. Am I right? Only what we can say that yes, they are going straight, but we are unable to certain the position. So now what will happen? I will decrease the slit, Then as I decrease the slit, what I notice that on the screen, practically what we notice that, so definitely we expect the photons will move. So no, the photons now what will happen? They'll start getting scattered. So this photon will reach here, this photon will reach here, this photon will reach here. Tell me like now, what we are certain, as we are certain, no, the photons are passing through this very narrow slit. And what happened there? Momentum. They change their direction. No? And can you say now, here what you can say as they're having momentum in this one, towards right. And we are unable to judge that where this photon is, this photon, where they are. We are unable to judge that delta x. There's uncertainty is there. Delta x is highly uncertain, and momentum is what? Is less certain here. That what about here? Delta x is certain. The delta p is what? Uncertain. Tell me, can you say which photon in what direction will move? No, you're unable. But you can say as the photons are here. But sir, here also I see photons, but you cannot say which photon where it is. Only you are able to say that momentum of photon. How do you can measure momentum of photon? As from radiation chapter, everything you know, force, I can say that the momentum of photon is in this direction. But which photon, where it is, we are unable to locate the position of photon. If you make the slit very narrow, very narrow, then yes, you can say that the photons are lying in this region. What about here? The photons are lying in this region. So what happened? The probability of location of photons has increased here, delta x. Getting the idea? What is the probability of finding out the photons? The delta x got decreased, but they'll get scattered. You can see the beam will region in which photons strike. So this much will be there. Able to understand now? So this is thing. So delta x is less, delta p has become more. Here what happened? The delta x is more, delta p is less. This is a very practical. So why this is happening? Tell me, is it a problem with our laser beam? No. Is it? This was the nature. The behavior of nature is like this. So these are conjugate variable. Like this, what happened? We have temperature, entropy, pressure, volume, energy, time. So like this, when you go for measurements, no. So what are conjugate variables? Temperature, entropy. Next again, energy, pressure, volume. Energy, time, current and electric field, surface tension, surface area. All these are conjugate variable. Now elastic force and length. Next, force and speed. So all these are conjugate variables. Delta F into delta V should be greater than or equal to h by 4. It cannot be made less than that. There will be uncertainty. That's what it's telling. It will be greater than, but it can never be less than h by 4 pi. This is the rule of nature is telling. So what you can say, delta x is more. I think I'll put in very simplified way here. Delta x is less. The probability of finding out photon here is, the position is what happened is more. Either it can be here. Here it is less. But I know that they are moving straight. The momentum. Here what happened? As delta x decreased, delta p got increased here. And there's no other way. We can never make equal to 0. It should be always equal to certain value. H by 4. It cannot be less than this. That's what the uncertainty principle is telling. So not only just momentum and this one. So if you go for any system, there'll be conjugate variables. So we should identify what are that conjugate variables so that we can take care in designing that system. So what is all the engineering skills are? So when you construct any system, no, so you should search for what are the conjugate variables. What are the conjugate variables? So these are the conjugate variables. You should search for the conjugate variables. Then you have to take care in designing the system. Okay, I'll stop the class. Okay, thank you, all of you.